So I'd like to invite Dorian Robinson to just give a little bit more of the details about the practicalities of this work. So Dorian, I'll hand the microphone over to you.
Hello everybody. So I'm going to follow up on the presentation that we just had and going a bit more into some details of the approach that we implemented in the field. I'm skipping this. So Arjen presented the scope of all the project and the activities that we did there, and I'm going to focus more on the part about the training and the lab installation and material that we used in the field. Also about the scheme improvements and the activities that we did in the water schemes to improve the water safety, and the monthly monitoring that comes as a support for interventions. So in the 5 intervention schemes where we saw that there was an improved water quality after intervention, we applied a risk-based strategy with these field laboratories, and important aspects was the capacity building of the local people that were involved in all the phases of the project at the laboratory level, but also at the community level and the scheme inspection. So we call it Adapted Water Safety Plan, or as Madan said, Water Safety Plan plus plus plus, with this improvement and this additional monitoring that we did. Sorry. So the risk-based approach for safe drinking water, with this adapted water safety plan and the local capacity building, what was done in the field is that there was creation of the water safety plan task force that was responsible of planning and helping to implement the water safety plan that was planned. So one of the big activities that we did at the beginning was a sanitary inspection of the whole scheme with this water safety plan task force to understand where were the weaknesses of the water scheme and how the water could get contaminated, and to capacitate the local people to understand how it works and how the contamination can go into their drinking water system. So here in the picture we see actually the people checking some of the structures of the water supply scheme for this sanitary inspection. So mainly capacity building and establishing afterwards measures for improvement of the safety of the water. So as mentioned before, sources are one of the main points where we worked because they are very vulnerable. Sorry. Here we see a picture where the source is mostly not protected. So contamination could come from rainwater, for example, into the drinking water supply directly. So with the interventions that we did in the field, so there was source protection with also surface runoff diversion to protect from runoff contamination, and also intake improvement. So we see on the picture here installation of a sand and roughing filter as a second measure after the source protection, and also 3R measures, so recharge, retention, reuse at the source, which are measures that will give impacts in a few years because trees and everything have to grow until then, and this helps the source protection measures. Then other activities that were done was training the local community to perform improved maintenance on the scheme and better cleaning practices of the scheme overall, because we noticed that in some parts the maintenance was not so good. And also the last point was chlorination that we implemented in 2 of the schemes. We see a picture down here where chlorination is done. So for now, chlorination is done only by pouring chlorine into the reservoir tanks, and we are looking into ways to do passive chlorination for the further steps of the project. Alongside with these improvements, there was also this hygiene and behavior change campaign and household water treatment and storage promotion with the use of these ceramic candle filters that you saw in the results that made the household water treatment levels reach 100% at the intervention schemes. So altogether, all these interventions are making a multi-barrier for the protection of the water. Because if we have only, for example, one of the barriers and this barrier fails, then the other ones would be there to protect the water in a better way. And this is just a picture of the participatory approach that we implemented with community people learning how to do the chlorination in their water scheme. So now one of the questions that we are going to look together is how to monitor this drinking water quality in the rural areas. So we talked about, the regional labs that are very good labs that can perform all the analyses that are needed if they work properly, but it's very difficult to have many of them and that it covers the whole Nepal area. Because travel times should be very short for water quality analysis of microbial parameters. So then there is this field kit that can be WACTEC or Delagua, or maybe there are others, that are very useful because they are fully equipped and we can go to the field and check the water quality with this. But they are very expensive, they require a very trained person to use. And actually, if you want to cover the full area of Nepal, for example, it would demand a lot of travel between places, which might not be so sustainable in the end. So our approach is a decentralized lab unit that is a very simple incubator that works on solar power. So it stays close to the locations that we want to monitor. It can incubate at 37 degrees for 24 hours, what is needed for microbial testing. It's solar powered, and so this is like an intermediate solution for the water quality monitoring in the rural context that is working quite well. So the field laboratories are equipped to measure E. coli and total coliform with filtration kit from the Lagua, compact dry plates that are materials, plates that are ready to use and sterile, so it's equipment that can go to the field and stay there and can be used easily even in the difficult conditions of the field work. As well as these membrane filters and well packs bags to take samples. Everything is sterile and ready to be used in the field. So I have some of the material here. I'm not going to show it now, but if you're interested in seeing all of this material, we can have, you can come to the table at the end and check all of these. So on the right, we see the incubator and the solar setup that we installed in one of the labs. So these incubators are field-robust, solar-powered incubators for microbial water quality. And this is one example of a compact dry plate that gives us the results for microbial water quality, E. coli and total coliforms. So the incubator that we see here is the first version of the incubator, is the one that we used in the field until now. And this second incubator is the new version, upgraded one, that is, what is upgraded about it is that it can be constructed with very common electrical material and a shell that can be found anywhere. Here we use the cooler box, for example. And with this kind of material, then it's also easy to repair and to use it in the field conditions, because this incubator can be built by somebody with the material that we developed and be ready to use anywhere. And it's also interesting because the size can change. So if you need a big incubator, you can build a big incubator, and if you need a very small one, you can build a very small one. Additional parameters that we are starting to test for the following phase is the turbidity and the pH and free residual chlorine. So with for the pH, we have these Delagua tubes that is a very simple tube that you use for testing the turbidity. And so this is a pool tester kit which is very useful for testing this pH and free chlorine, because it goes it's very small and it goes together. So you always need these two parameters when you check water quality for a chlorinated scheme. So the location of the laboratories was an important decision in the project, because so we had to find a place where the walking distance was close to these water schemes, and that one important thing is that one lab can cover several water schemes. So we can see here laboratory unit, and it can cover. We have worked with only 4 schemes for one lab, but actually it could cover many more if they are around the laboratory, which is interesting. Another point is the availability of staff that can be trained. So for that, we selected 2 places where there was educated persons that could be trained. So a health post and a school were the locations of the laboratories that we installed in this phase. So the laboratories, they are operated by trained local staff, and they can cover several schemes. A few pictures of, okay, I made a mess, sorry. So some of the pictures of the training that we implemented in the field. So we can see on the left, it's a training of a member of the community of the Water Safety Plan Task Force that is being trained to take water samples from his water scheme, and in the end he will bring them to the laboratory to be tested. And on the right, we see also a member of the community that is in charge of sanitary inspection of the scheme. So these both persons, they use a tablet for this work, and the tablet helps us then to upload the data directly on the cloud and be able to have different persons that are interested in this data to use it. And in the bottom here we see people that are being trained for the laboratory work, and in the middle, part of one of the protocols and documents that we created for all these trainings. So all these trainings are available in English and in Nepali, if needed. So the next point is the costs of the laboratories, which is an interesting question. So I don't go into detail of everything, so I just will present the total. So the upfront costs for the laboratory setup, it's around $700 for one lab, equipped with the microbial testing, turbidity, pH, FRC tests. And then you have consumable costs. For example, for the water quality, the microbial water quality is $2 per test. And for the FRC and pH is 50 cents per test. A bit more detail about the regular monitoring activities. So these regular monitoring activities are about water quality and sanitary state, so sanitary inspection of the scheme. So for both, on one side we see here the laboratory staff that are performing this work. So they were trained in a group training at the beginning, and then in the field they were having follow-up trainings until they were able to manage the lab on themselves. And on the right we see again a community person that is taking water sample from his scheme. So both of these teams, they always communicate because they have to work together to bring the samples, to do the testing, and to bring back to the community the results of the tests. And additionally, there is this centralized data management, as we said. So all the data of water quality and sanitary inspection risk scores that go on the cloud. And here on the right is the places where we monitor the water quality and the sanitary state. So at the source, reservoir, tap, and household. Battery. Thank you, madam. Okay, so here is a risk table. So when you have to decide about an intervention, you can check about the water quality and the sanitary inspection score. So both of them indicates you if there is a need of intervention at that point. So this is to resume what we do with this water quality and sanitary inspection test. So monthly, there is this scheme inspections and water quality testing in each of the schemes. With this data, then it's analyzed or by us or at the community level where it's discussed, and improvements are done if necessary, and actions are taken to improve this water quality. And we see on the bottom backstopping from any person responsible of the scheme or an NGO that works there that can then close the loop and this helps to inform all the decision-making process and target what are the urgent actions that have to be taken to protect the water safety. So just a few conclusions. So we saw before that there are promising results achieved with this risk-based approach, including the laboratories and the monthly monitoring that helps support all the decision-making processes to improve the water safety. There is an increased involvement and awareness raising of the community because they have been involved in all the steps of the project, from planning with the water safety plan and all the monthly activities that are done for monitoring. And the monitoring that is performed there complies with the demand of the monitoring guidelines of the national monitoring guidelines. So not the water quality guidelines, but how many times we have to monitor the drinking water in rural areas. So the next steps is scaling up, as Arjan said, and improve the strategy based on the lessons learned. And few of the challenges that we are facing is material supply chain, training and capacity building at a larger scale, and cost and who pays for everything. That's it.
Thank you very much, Dorian.